Hi everyone. Today we discuss about new concept, a modified multi-level inverter with inverted sinusoidal pulse width modulation control. So where this model will be refers to means whenever the input DC voltage having intermittent power, suppose if you take solar, wind, fuel cells, supercapacitors, okay. So these energy sources having low DC source, okay. So in order to boost up the voltage, we are using boost converters. And then that DC voltage is given to the inverter to convert DC to AC conversion. And you know that basic conversion of DC to AC will be are of three types. One is cascaded, second one is flying capacitor, and third one is diode clamp. So in apart from these methods, these methods having, that means conventional multi-level inverters having some disadvantages. It does not boost the voltage. Okay. So, for example, in boost converter, we required LC components and also one switch. And to maintain ripple free, you are placing one capacitor. And then if you take an inverter requires overall six switches. Okay. And also the will be the inverter operation will be majorly depends upon the DC link voltage only. Okay. Suppose if the DC link voltage is less means the output inverter voltage will be less. How we are judging that inverter output means with the help of the formula we have. That means if you consider line voltage 240 means we are having one formula VDC is equals to 2 root 2 V LL divided by M into VDC. Okay. So this is the major formula for the to find out the VDC. Okay. So in this paper we discuss about the modified multi-level inverter. Okay. Apart from the cascaded flying capacitors, diode clamped, apart from these designs, we are using a novel multi-level inverter. So what is the advantage of this modified multi-level inverter? I will tell you each and everything. Okay. So, in whatever the modified multi-level inverter uses boost converter with charge pump principle. Okay, capacitor charge pump principle is already referred in some base papers. If you've gone through the reference papers, you can get that details. Okay, so the role of the boost operation with charge capacitor charged pump means to boost the voltage, to boost the inverter voltage. It is possible in this design. In previous designs, whatever the capacitors place a different role. When you take a flying capacitor, neutral diode clamp, it will be different. Okay, that concept is totally different from this concept. Okay, so in this concept, majorly boost converter along with capacitor charged pump plays a major role. Why? Because it boosts the voltage. Suppose if you take an input voltage 110 voltage, it boosts up to 1 point, into 1.5 times. That means nearly 220 voltage. Okay. So this is the advantage of the proposed multi-level inverter. And come to the block diagram. So this is converter, 5-level converter, and proposed 9-level converter. I will show you these models also. I will show you here. So this is the 5-level converter. So suppose if you run the model, in a meanwhile, I will run the remaining 7-level and 9-level also. So in this paper, we proposed 5-level, 7-level, and 9-level multi-level inverter. So what is the role of the 5, 7, and 9 multi-level inverters? I will tell you. So the role of the multi-level inverter is you need to get less THD value of the voltages and currents. So how we are going to control the THD value? Means by the use of the multi-level inverter. This is the advantage. By using multi-level, why we are proposing multi-level inverters means to decrease the THD values. THD means total harmonic distortion. I will show you here clearly. So this is the five-level multi-level inverter output, voltage and currents. The voltage range will be 200. We are giving input. 100 is the input for this multi-level inverter, not this one, five level. Okay. This is 100 is the input for this level. So output will be 200 voltage. Output will be 200 voltage and the current will be 2 amperes. These are the pulsing circuit. This is the inverted pulse width modulation, sinusoidal pulse width modulation technique. Okay. For each level, they already mentioned at which time interval the switch is going to operate. This will be shown in this block diagram Q1, Q2, Q3. At which time intervals the level will be included here. The levels will be shown 0, 1, 2, 3. Okay. The level depends upon the type of level, multi-level type. Okay. If you take 5 level means 0, 1, 2 only you need to count. 7 level means you need to count 1, 2, 3. Okay. In a meal manner, if, suppose if you want to increase the level means the switch count also increase here. Okay. And here majorly already I told you na capacitor charge pump type application. So here series connection switches will be mainly used for charging purpose, and parallel capacitors will be majorly parallel switches are mainly used for the discharging purpose. This is the major role in this design. Where this design will be used means for renewable integrated grid integrated type applications. Suppose solar with grid integrated type, we can use this design. So if you see the five level means, I will show you with the THD value here also. So five level THD value will be 25.444 percentage. Okay, 24.5 percentage is for five level. Suppose if you consider seven level, the structure will be similar like that. We just need to increase the design of this one. We need to add on one more design like this way. Okay. Here only with two models will be taken. Okay. Suppose if you want to increase the level means again one more design you need to place here. Okay. Suppose if you want to increase another level means in a similar manner you need to increase one more. Okay. Design will be similar. Suppose if you want to increase the level means again one more design you need to add on. And this one is the seven level multi-level inverter output. So the levels will be increased like this. 0 to count 1, 2, 3. In the main one, this also 3. And 0th is the 1 level. More is 7 level. This one is the 7 level. Suppose if you check here for 9 level. Okay. So 0 to count 1, 2, 3, 4. Okay. This is the 9 level multi-level converter. And we need to check the THD values. And here in your base paper design, they already given the level type inverter with the THD values. Okay. I will show you this THD values, comparison of the 5, 7 and 11 level inverter. So 5 for 5 level THD value will be 25.4 na? So go to the PS power guide and look for the FFT analysis tool. So 7 level, if you display the THD value, but if you increase the level, the THD value will be decreased. That means here 16.95. Okay. Suppose if you go through the 9 level, the THD value will be 13.50. Okay. So suppose if you reduce THD value less than 5 voltage means you need to increase the level of the converter. Okay. This is the advantage of the proposed design. It can be used at anywhere. Suppose wherever the applications take a place role of DC to AC conversion, you can place there. Okay. So this is the advantage of the proposed design. Thanks for watching this video.